Good morning, this is Mike DeLaCluse at Lesman Instruments. I'm showing right at 9 o'clock, so we are going to go ahead and get started. I'd like to thank all of you for taking time out of your busy schedules to join us for Flowmeter installations, the end of 5 up and 2 down. Our presenter today is Lesman's own Dan Weise. Today, Dan is going to change the way you think about Flowmeter installation. The rule of thumb that requires you to have 5 pipe diameters up and 2 pipe diameters down of straight run pipe for accurate measurement may be outdated for many of your installations. By the end of the session, we hope to give you some insight as to where you can throw the rule out and where you'll want to stick with it. Dan's been involved in all facets of process instrumentation since 1978, from sales and commissioning to service and support. He's a longtime member of ISA and has been with Lesman since 1988. Dan is the primary contributor to our Process Solutions blog and routinely travels to Lesman customers to help solve their instrumentation problems and help them get the most out of the technologies they use. In his words, Dan's the guy who reads all the manuals nobody else reads. In Lesman customer words, he's the trainer to call if you want someone to cut to the so what of instrumentation. The phone lines will be muted. If you have any questions, there is a question tool built into GoToWebinar. Please send me the questions and I'll get them answered. With that, I'm going to turn it over to Dan.
Hi guys. As Mike mentioned, I've been in this for a long time, as a lot of you have probably been doing this for a long time. So we have to take the historical perspective here that we've always heard that a mag meter needs 5 diameters upstream and then 2 or 3 or 0 downstream, depending on who the vendor is. And that's just been like gospel. You have to have that. And if you don't, your accuracy just goes down the tubes. Here's some examples of various vendors and their suggestions. Here's Foxborough with 5 diameters upstream, 3 diameters downstream. Rosemont says 5 up and 2 down. Yokogawa sort of bit the bullet there and said 5 up and 0 downstream. Of course, they have the restrictions for valves always being downstream, like most people do. E&H is 5 up and 2 down. Toshiba came out and said no straight pipe length is needed on the downstream side. Again, they actually stated that 5 up, 0 down. Of course, they got the valve on the downstream side down there, which is always acceptable practice. So everybody agrees also that reducers, which are frequently used to, because the mag meter is a smaller line size than the pipe sizes, and the reducers are used in the smaller tube size in order to get a higher velocity, that you can close couple those and that does not create an accuracy issue. And they show this as a graphic right out of the Siemens manual that shows the use of reducers. So reducers are not an issue. But some straight line pipe is always needed to correct the anomalies that occur with the turbulence caused by upstream non-straight piping, T's, elbows, and everybody that I've ever seen agrees that valves should be downstream. So this is the historical conventional wisdom. You know, we got to have this straight pipe run in order to make this all work. With all of this, there's never any statement about, you know, what happens if you don't do that? How much error is there really? And we handle Siemens, so we have access to the Siemens clamp-on flow meter. And this is a clip out of their manual that shows that they actually have a factor that corrects for upstream pipe anomalies. And you can see the different configurations there, but there's no number associated with any of this. We don't know whether it increases or decreases or by how much or how closer you get to rated accuracy if you use this. It's just sort of a statement out there. Back in 2010, there was an article that ran in Flow Control magazine, and you can see in red there, this really caught my attention. Errors from piping effects generally run between 0.1% and 1.5%. And this was specifically for mag meters. And I was astounded. I said, wow, you know, all this time I thought we were probably getting 10 or 15 or 20. Who knows? Because there was never, you know, a statement from an authority that said, you know, this is what the error can be if you have these upstream anomalies out there. Then recently here, within the last year or two, Toshiba bites the bullet and they come up with their Mount Anywhere mag meter. That comes in all 3 styles, flange, wafer, sanitary. And these are the restrictions that they have stated in their spec sheet. You get better than 0.5% of rate accuracy when you're only 1 diameter from the flange of an elbow, and I presume they mean or valve, and line size is up to 18-inch. And they're saying so there's no need to repipe the process if it's closer than that. And they spell out what they're doing here for their full performance spec. Now, if you want the rated accuracy, you got to come back and you got to do the stuff that's in the diagram right here. That's not for the for this new no upstream, no downstream type stuff. And you do need a minimum of 1D or 1 diameter upstream from the flange in order to maintain the performance spec. That goes back to the previous page there where you got to have the you have to have some minimum piping in there in order to qualify for the rated accuracy. So this really calls people into the ring here. So Siemens puts on their gloves, they take notice, and they put their 5100W flow tube on a flow stand and make some measurements. And the measurements are defined right here, so it's worth taking a look at it. They start out with a baseline. They actually pipe it up so it's got 5D upstream, 3D downstream. It's tested, and then we're going to see what the results of the 6 different configurations are, but each test was repeated 4 times, and the results are averaged. And they did it with they have 2 different electronic boxes, one at 0.4% accuracy, one at 0.2% accuracy, and they used the one with the 0.4% accuracy, the less accurate one, because that's the 90% one that most people buy, particularly with that 5100W2. So they made a standard package of this for people that were actually going to consider buying it. So here's a photograph of the reference conditions where we've got a spool in there, but it gives us the upstream 5 diameters upstream, 3 diameters downstream. Gives us, this is considered an error of 0% because it's the baseline at this point. Then they close couple a gate valve right next to it. Error, 1/3 of 1%. Then they close couple a T to it. Now, note that they don't have, because it's a float stand, they don't have full configuration here, so there's nothing going into the branch on the top there. But again, T's up there, less than 0.5% error. This one really got my attention right here. 2 T's, 2 90-degree elbows, 0 degrees up, less than 0.5% error. Now, notice in this case, the orientation of the electronic box right here. It's actually in line with the flow stream, so that means that the electrodes are going to be at 90 degrees, because in the next slide it's going to be the same thing, but we're going to rotate the electronic head 90 degrees. So here's the next one. You'll see that the head is now facing us, so now we've rotated the electrodes 90 degrees, and now we're at, again, less than 0.5% for this kind of configuration with all the flow and turbulence and stuff that's going on there. You're at 0.5% error with this configuration. Here's our 4 elbows in this case, and I was actually more surprised with this one that compared to the earlier one with the T's and the elbows. Here we got nice, curved surfaces in the elbows, and the accuracy actually almost, or the inaccuracy doubled to less than 1%, about 0.9% there. And again, this rotates the head in the opposite direction, and surprisingly, the error drops significantly just by rotating the head or the meter body by 90 degrees, so that the electrodes are in the 90-degree orientation difference here. So we're calling this 0 up, 0 down, and as a result of these tests, Siemens MAG 5100W tube has received an MI001 custody transfer approval, which is a European approval. And I'd just like to point out that Toshiba tested it themselves, at least that's what they claim right there, Toshiba's flow calibration facility. Siemens actually used an outside agency, so this is not something they just did themselves to garner up the numbers. They did it by a third party, so I don't think we can assault the actual numbers they got here. And there's a little bit here on this MI001 approval, and it's primarily for custody transfer in water, in potable water. And I believe what it does is it says that down here on this part of the curve down here, as long as you stay under the square, under the limits here defined by the square, that you can meet that spec. And it does it. So even with these oddball flow perturbations coming from the upstream piping. And there's a little bit more here. Some customers in the U.S. apparently accept this. Other people don't. They want an NTEP approval on it. It is what it is. And I guess I got to put it out like this, that at least somebody has come out with some numbers now for what these kinds of errors are. There's no guarantees, you know. It's sort of like the panel that you get on a new car here, you know. They took a whole bunch of averages of a whole bunch of drivers on a whole bunch of cars, and they come up with 23 miles per gallon in the city and 30 on the highway. What do you actually get? Well, it depends upon the way you drive and the route that you drive, that kind of thing. But the question that I put to you is, can you live with an error of this magnitude? With that kind of piping, which is really bizarre and nobody really has it anyhow, but there's a 0.5% error with that kind of piping right there. So this was really revelatory to me, because I just expected numbers that were an order of magnitude higher than this kind of number right here. So, and I suspect most people out there probably did too, because there was just no reference for it. This has changed the way that I think about mag meter installations, particularly if it's greenfield and you're putting it in the first time, you can probably afford to put the meter run in. And if you're looking for you know, a custody transfer accuracy, you're going to have to do it. I mean, that's just the name of the game. But in a lot of cases, less than 2% error is something that people can live with, because it's still a reliable, repeatable measurement. And in the process industries, as we've all found, repeatability is probably more important than dead nuts accuracy. So that sums it up for me. I think if there are any questions out there, we can try and field them.
Dan, thank you very much. Let's give it a minute here, see if we get any questions. It is interesting that this data has actually been created and exists out there, and I think it's important for people to understand that, you know, the data exists. Each application is slightly different, so it is going to vary. But you know, if you're stuck with piping that you're stuck with and still want a flow meter to put in, it'll still work. It'll just have an accuracy difference than what's actually published. Okay, I've got a question coming in here. Is this really only applicable in under 18-inch meters? Dan, do you want to try answering that one? I don't think we have an answer, but go ahead.
We don't. The 18-inch meter was the Toshiba limited it to that, and again, I don't know how they came up with that. And as I stop and think here, I don't know why it would actually, why that would change with pipe diameter. I guess I have to say I plain don't know. In fact, if there's anybody out there that thinks they know, we'd be glad to hear from you.
Yeah. Interesting part though is how little the accuracy did change.
Yes, that's the whole point.
When you're right up against an elbow or some other piece of piping you can't control. I'm not getting any other questions. So with that, I think I'm gonna start to wrap it up, Dan.
Very good.
Dan, thank you very much for your presentation. If anybody does have any other specific application questions, please feel free to give us a call at 800-9-LESMAN or 800-953-7626. If you don't know your account manager, feel free to ask for me, Mike DeLaCluse. I'll make sure you get taken care of. You can also reach Dan and I. My email address is miked@lesman.com. Dan's is danw@lesman.com. We have another question that came in here. When is it a bad idea to use the 0 up and 0 down rule, or 0 up and 0 down thought process? Dan, my first inclination would be any flow that isn't going to have a full pipe. If you don't think you're going to have a full pipe, don't go anywhere near it, because it's not going to work.
I can't reiterate enough that that's absolutely true. The assumption on all magnetic flow meter applications, well, I shouldn't say that. There are a couple specialty devices. We don't handle them, but there's some people that will claim partial pipe measurements, but it has to be a specific device claiming that. But the general 98% of the market, 99% of the market mag meter expects a full pipe. And if you don't have it, it's not going to work. The other thing you got to be careful of is aeration in mag meters. That's probably the #1 problem that I see when people start get bouncy numbers is aeration in the pipe, because the air is not actually, the air constitutes a non-full pipe. Those air bubbles are not liquid, and it causes a distortion in there, but that's a side issue there. Other than that, again, if repeatability is what you're looking for, this is the name of the game. If you need hard accuracy, you need to pull out the spec sheet and say this is what it's good to, and you're relying upon the calibration sheet that came with the meter, then you've got to do the 5 up, whatever down on that. But if that isn't the big deal, and you've got to have a measurement, and you're coming off an elbow, and you're looking for repeatability, this to me says the mag meter is the perfect solution.
All right, now we got the questions rolling in. Are these results backward compatible with all existing older meters? I think the answer to that is probably not all, but if you're using, you know, the 5100 with the 5000 electronics, it's the same meter. I don't see why it would be any different. Can you think of any reasons why that would change?
I can't either. I'm going to say if you went back to, you know, if you had a 1954 Foxborough, you know, I'm not sure that the electronics are running in that.
I think, you know, the impression that we get from talking to the Siemens folks is the reason why this is starting to show up now is because the electronics are getting so much better.
Yep.
And that's what's allowing some of this to happen, at least for us in the Siemens world. Next question, approximately how many of the 5100W meters is Lesman sold, and are there any water suppliers in the Chicago area using this meter? The answer to that is lots and yes. We have lots of water suppliers here in Chicago using our meters. Is an installation with a pump, in an installation with a pump, is there any problem putting the device on the suction side of the system rather than the discharge?
Can we get a name on that and get back to you? I want to check on that one.
That's a great question.
There can be issues with that, and I want to look at the exact construction on the 5100W. Let you know.
Yeah, because there can be problems, and we just got to make sure that we're reviewed before we have an answer to that one. All right, can you compare pricing of the 5100W versus a Rosemont 8732? I wish we could. The answer to that is this is a competitive market, and the reality is,
for the same category, mag meters there are process meters, and then there are water meters, then there are sanitary meters. Yeah. The truth of the matter is they're usually within a couple dollars of each other in any given category. You can't compare a process meter, what I would call a process meter with a water meter, because the linings are different, and the temperature specs are different. But within a category, they're usually within a couple bucks of each other.
Yeah, they're really close. I'm not seeing any other questions come in. Our next webinar is going to be August 25th at 9 a.m. It'll again be presented by Dan Weise. In our next webinar, we're going to introduce you to a new product from Honeywell that takes legacy analog sensors into a data format, also known as paperless recorder, data recorders, that sort of thing. But what Honeywell has done is embedded web services to that product with some OPC capability, so that now you can take your legacy sensors and web enable them, so that if you're on the same network, you can actually see those sensors from your PC, from your desktop. And all of this is backward compatible with the paper recorder, circular chart recorders that are in the market, so they fit in the same holes and make installation relatively easy. If you're interested in learning about the industrial Internet of Things, as people are calling it, you won't want to miss this webinar because it really is kind of the beginning of industrial Internet of Things and taking your old legacy sensors and getting them into Internet type formats. You can either sign up at our training center at lesman.com or wait for the announcement to come out shortly. And while I've been reading this, we've had a couple other questions come in. How does this relate to a large pipe like a 72-inch? I don't think we have the data on that, Dan.
We don't, but I just have to say we don't. Yeah.
Yeah.
Can't speculate.
So, at this point, if there are no further questions, which there doesn't seem to be, our presentation will conclude. Again, thank you all for taking time out of your busy day and attending our webinar. The next one, as I said, is coming up August 25th, and it's beginning the discussion on the industrial Internet of Things. Thank you very much for attending. Have a great day.
Thanks, guys.